Okay, for today's notes, we are going to look at distance, rate, and time. So kind of some information about distance, rate, and time. It goes right along with what we've been doing with our y equals kx. This time we're going to have d, r, and t. So d is distance. So distance is going to be, the unit we're going to see for distance is miles. And then r is going to be rate. Rate's going to be miles per hour, mph. And then T is going to represent time. And that's going to be hours or minutes. So I want you to write this down in the corner of your paper, or just make a side note about this because it's going to be very important today to know the units for each one. So we're going to go through 3 situations, one looking for distance, one looking for rate, one looking for time. The big thing is making sure you plug in the right information into the right letter. So it's a formula. You don't have to memorize the formula, but you do need to know how to use the formula. So we have D equals RT. RT is going to be multiplication. So Michael travels at a constant rate of 55 miles per hour for 4 hours. How far does he travel? So constant rate is going to be 55, so that's our R. 4 hours is our T, so that's going to be our time. So that means we are looking for D. So if the question says travel, that's going to be our distance. How far does he travel? So we're going to multiply 55 times 4. And so we get D is equal to 220 miles. Okay, next one. Melody travels at a constant rate of 65 miles per hour. How long does it take her to go 195 miles? So long is talking about time. And if you look, there's no time in the problem. There's no hours. So we have rate is 65. Miles represents distance. So that's our D. So we're looking for our T. So this is a unit rate problem, or it's kind of like unit rate. We want to know what is T. So it's a one-step equation. So we're going to divide by 65. And that's going to find us what is our T. So 195 is on the inside, 65 on the outside. And that's going to go in there 3 times evenly. So 3 hours. Okay, and when you're talking about time, if you get some crazy big answer like 35 hours, that's something that you're not going to see with 195 miles. So hours are always going to be really small numbers. Miles are going to be pretty big numbers. And then again, when you're driving a car, you're going to have kind of basic speeds like 65, 55, 45, 70, etc. Okay, last one on this side. So Martin travels 300 miles in 5 hours. If he was traveling at a constant rate, what was his speed? So I'm going to go back up to the top. So speed has to do with rate. And then I'm going to go ahead and add this for time was long. Okay, so we have our formula, D equals RT. Miles is our D. 5 hours is our T, so that means we are looking for our R. Okay, so we have to ask ourselves, what times 5 will equal 300? So again, it's a one-step equation. We're going to divide by 5 to get R by itself. So we have 5 into 300. 5 will go into 36 times. And then bring down our 0. 5 will go into 0 times. So we get R is equal to 60 in its speed. So it's miles per hour. Okay, so if you were dividing and you get 6, think about it. You're driving a car. You're not going to drive 6 miles per hour in 5 hours. It's going to be a whole lot longer than that to get 300 miles. So again, kind of think about common sense things when looking with distance, rate, and time. All right, so let's look at 3 more problems. So So Jackson traveled at a constant rate of 15 miles per hour on his bike for 1.5 hours. How far does he travel? Okay, so this time we're talking about a bike. So speeds are going to be a little bit smaller. Distance is a lot smaller as well. So miles per hour is our R. 1.5 hours is our T. We're going to change that to be a decimal. So we are looking for our D, which is our distance. How far does he travel? So we're going to multiply 15 times 1.5. And so D is going to equal 22.5 miles. That is his distance. So in a bike, he went 22.5 miles. All right, so let's look at this next one. Jill travels at a constant rate of 18 miles per hour on her bike. How long did it take her to go 12 miles? So we write our formula. D equals RT. 18 miles per hour is our rate. 12 miles is our distance, so we are looking for our time. So again, it's like a one-step equation. So we're looking for T. Divide both sides by 18. So this one's kind of a weird setup. So the number on top is going to go on the inside, 18 on the outside. So 18 can't go into 12, so we're going to add a decimal. 18 is going to go into 120. Six times, which is 108. And then it's going to keep repeating. So we get 0.66. This is our time, hours. All right, so our last one, John traveled 24 miles in 1.5 hours on his bike. What is, if you try to concentrate, what was his speed? So 24 miles is our D. Our time is 1.5. So again, we're looking for our R. We're going to divide that by 1.5. So the number on top is going to go on the inside, 1.5 on the outside. So 24 in, 1.5 out. Move our decimal over 1 in both numbers. 15 is going to go into 24 one time. And then 15 will go into 96 times. 15. And so R equals 16 miles per hour. All right, so now it's your turn to work on your homework. You're going to have one of each situation. So write down the equation and then plug all your numbers in.